All right, so welcome everyone to day 8, the last lesson in module 1 of our Python Developer Bootcamp. Today we are going to cover new concepts. We are going to look at new tools in Python. We'll be talking about what is called data structures in Python for us to be able to perform advanced manipulation and be able to write advanced code to solve real world problems. So this is where the fun begins, and the rest will continue in module 2, where we learn the advanced concept that will be used in the real world. All that we've covered so far are the basics, and if you have missed any lesson, please go back, watch all the videos, and any exercise or any assignment that is given, make sure you try it out. And again, make sure you use your own, solve it in your own way. Do not make use of AI, because if you try solving it yourself, you get to challenge yourself, you get to think critically, and you get to solve the problem on your own. And that is what makes you a developer. That is what makes you learn. That is what makes you acquire the skills. So we want you to take your time, solve all of them, try and solve them. And if you can do that, you will move forward. I'll do a little recap of what we studied yesterday. We looked at the signature of the print function, how the print function was created. We saw the sep parameter, we saw the end parameter, and we were able to manipulate them. We also took a look at the IDLE yesterday, which is an integrated development and learning environment, particularly designed for beginners and learners to be able to write simple Python scripts and explore Python in the IDLE. We also got introduced to the wonderful Jupyter Lab, which is an incredible tool used in the field of data science, AI, machine learning, data analytics, and in scientific computing. And it allows you to create Jupyter notebooks. And we looked at Jupyter notebooks yesterday. And Jupyter Notebook alone is a tool you can use alone, but it gives you a single interface for you to create your notebook. If you use Jupyter Lab, you get a more flexible, more interactive environment to create multiple Jupyter notebooks within your Jupyter Lab. And there is another one that I wanted to mention yesterday. Let me go ahead and show you. And let me quickly share that and show you so that you get to hear of that as well. So that next time, if you need that, you'll be able to use it. All right, so I'm going to share this rather, and you have to try it out as well. So there's another one called Google Colab, and I'm sure you've heard of Google Colab. When you go to Google, you can just search for Google Colab. If you have a Gmail account, it is free to use. And this Google Colab, you can see here that it is a hosted Jupyter Notebook service that requires no setup and no installation, provides free access to computing resources, including GPUs and advanced resources for you to run your Jupyter Notebooks. So if you don't want to do any installation on your system, you can still work on Jupyter Notebooks using Google Colab. So when I open to Google Colab, I can just click on New Notebook, and I can run a web version of Jupyter Notebooks. This is free to use again, and it is very, very powerful as well. So instead of installing Jupyter Lab or Jupyter Notebook, again, Jupyter Notebook is a standalone tool. So you can install Jupyter Notebook, or you can install the advanced version called Jupyter Lab. So over here, if you come here and you want to print your hello world, it's the same thing, and it works. So you can change the theme. You can use dark version or light. I mean, the dark version looks calmer on my eyes, so I like to use the dark version. And you can see that whatever you do works. So you can use this for your machine learning, use this for your data analysis, use this for your all your notebooks. You can do that with this one. All right. So let me go ahead and share. And we discovered that the Jupyter notebooks operate under a shell that is different from the standard Python shell. And this shell is called IPython. IPython. We also mentioned that the file extension of Jupyter notebooks is IPyNB, standing for Interactive Python Notebook. If you are using VS Code, you can create a notebook, and I'll be happy to see if anybody has been able to create a notebook in VS Code. And once it is a notebook and it is an IPy environment, even in your command prompt, you can run your IPy environment, IPy shell in your command prompt and be able to create notebooks in your command prompt. So this is a quick recap of what we discovered yesterday. And today we want to move on. And Muhammad Ali says that don't count the days, but make the days count. Make the days count. So every single day is an important day. Every single day is a new day to learn new skills. So today we have something new to learn. So when you join the bootcamp, don't just count the days, counting when will be done, but make sure that every day counts. So let's make today count. If today counts, you are going to learn something new today, and you are going to upgrade your skills in Python. All right. So we want to move straight into the lesson, and we are going to talk about data structures in Python. Please type data structures in the chat for me. Data structures, data structures, data structures. And when we mention data structures, we are simply talking about how the computer system intelligently manages data in memory. All right. And data is stored using various structures. And so we want to take a look at them. And we have this begins with what we call data types. All right. So we'll be looking at basic data types, which are the ones we have discussed already. And the data structures are the advanced data types. And this allows Python to store data in more advanced structures. And we'll be introducing a concept called containers. And it says exploring containers in Python, creating and using lists and tuples. So in part one of our data structures, we are going to focus on what is called lists and tuples. And in part two, we'll be talking about sets and dictionaries in Python. All right. So to talk about data structures, we begin with what is called containers, because all these data structures are containers in Python. A container is a fundamental concept in Python that allow you to store and organize data effectively. These containers help you keep data organized in your Python program, making it easier to work with different types of data in Python. Python offers built-in container types such as lists, tuples, sets, and dictionaries. So today, the data structures we are going to look at, we are saying that they are also called containers. And so when you hear containers in Python, they are the same as the data structures we are looking at. And there are four that we are going to look at. And these are also considered as data types. So in Python, when you are asked about the data types in Python, you are free to mention the 8 data types we have looked at. The first 4 are called the basic data types. And when we say basic data types, we are simply talking about int, we are talking about string, we are talking about float, we are talking about bool. Those are the data types we discussed previously in lesson 2, and they are the basic data types. Now, the complex data types are the data structures or the containers that we are going to cover today. And today, there are 4 of them that we are going to look at. At the end of this lesson, I'll be happy to see someone who can recall all the 4 data structures we have in this lesson. We have lists, we have tuples, we have sets, and we have dictionaries. Just as you can store data as an integer, you can store data as a list this time. A list is more complex. A list is having more advanced features and allows Python to store multiple values in one variable. So that is what we are going to look at. And these containers are commonly referred to as data structures in Python. They are fundamental tools for organizing and managing data within a program. All right, so for you to advance in Python, these are data types that you need to be familiar with. They are really, really fundamental to understanding Python and advancing in Python. So apart from the 4 data types that we talked about previously, these are new ones that you need to keep. All right. So the first one, we call it lists. Then we have tuples. Some people pronounce it as tuple. I think it is tuple. And then we have sets, and then we have dictionaries. So these are 4 data types, and these are referred to as complex data types in Python, and each serves a different purpose. Each serves a different purpose. All right. Now, these 4 containers allow you to store data, just like the data types we covered previously. However, they do that in a more complex way to allow you to store more complex data within your program. Now, data can come in very, very basic formats, or data can come in more advanced formats. And so Python allows you to be able to store your data in various structures. All right, so let's look at lists. Let's look at list. Let's look at list. All right, so in Python, a list is a container that is versatile and can store a collection of items. Right now, if I ask you to create a variable and assign it to an integer, you can just do that, okay? You can just create a variable, assign it to an integer. Let me see if someone can do that for me. So if you can do that, just create any variable and assign it to any integer. Let me see if you can do that. All right, so the first person here to get this done is Robley. And Robley says num is equal to 5. All right, so this num equals to 5 is storing a value of 5. So 5 is the data we are storing in memory, and we are using the variable num to allow us to store it. When it comes to creating a list in Python, Python does not use list to store just a single value. With list, you can store a collection in one variable. So instead of storing only 5, you can store 15 numbers in one variable. So sometimes to make your program more intelligent, we allow you to combine data and store it in a special container. This is why list is referred to as a container that can store a collection of items. We also refer to list as a sequence, and there are several data structures that are sequence. Even a string is a sequence. So later when we get to loops, we'll be talking about sequence. And when you have a sequence, it means you can create a loop through the sequence. Now, these items that can be stored in the collection can be of various data types in lists. So the reason why we say lists are versatile simply means that you can store different data types within a list. Let me open to PyCharm and we will look at PyCharm. Let me load a new file called lists. and let's take a look at the list. So I'm going to share this. Let's look at the list and see how we can work with it. All right. So over here, I can create a variable here like fruits. And when it comes to creating lists, we will enclose it using the square brackets. Now, if I check the data type of fruits and I ask Python to print it, we are going to see that it is going to tell us that this is of a class of a list. Now, previously, when we created strings, we use quotes. If you use quotes and you run it, you are going to see that you have a string. Now, apart from strings, today we are looking at a new way to store data. And this time we use square brackets. And the square brackets here allows you to create a list. Now, this list can store a collection of items. This means that you can go ahead and store multiple items in it. So I can store a number in it, like 5, then separate with comma. I can store text. Let's say I have apple. I can also store more strings. Let's say I have mango. Let's say I have 4.15, which is float. I can store a Boolean value, which is true. And this still works. There's no error. It is still a list. And if I go ahead and tell Python to print the list for me, I'm going to see my list over here. All right. So what we are saying is that in Python, you can create another variable that does not store just one value, but you can store multiple items in it. It is so versatile that it allows you to store integers, it allows you to store strings, allows you to store float, allows you to store bool, allows you to store any data type that you have. As a matter of fact, it can store another list again. So let me come here and say I have list 1 and call this list. Let's say, let me put some numbers in it, 1, 2, 3, 4, 5. And in my list here, I can store list 1 as well. So when you run this, you are going to see that list 1 is also stored in this list. Now, this is a special container in Python that we use to perform advanced computation, and it is called a data structure that is versatile and can allow you to store any type of data that you want in your program. All right. Let's go back to the slide. Now, think of a list as a flexible container that allows you to store multiple values within a single variable. So with a list, you can have multiple values and store in a single variable. Unlike other variables that can store a single value, lists can store a series of elements, including integers, strings, and floats, and they allow for different data types to be mixed within the same list. All right, so this is another data type that is more complex and structured in a way that you can store different data types within it. All right, when it comes to lists, there are certain features of lists that we should know about. And one of the first features is that lists are mutable. Lists are mutable. Now, when we say lists are mutable, it means their values can be modified. Now, most of the time, when we want to use these data structures, we are supposed to look at the features of the data structure to know which one to use. Remember, apart from lists, we are going to look at tuples, we are going to look at sets and dictionaries. Now, lists are mutable and it allows us to change the values after creation. For example, if I come here and I go back to PyCharm, if I go back to PyCharm, I have this list here called fruits, and I can see that I have numbers and other values within it. What I can do is to tell Python to print index 0 of my fruits. If I run this, I'm going to see the value 5 because lists also work with the concept of indexing. Later, we'll discover that list also works with the concept of slicing. And so I can create a slice of my list. And when I run this, you can see that from 0 to 3, I got 5, apple and mango. This is index 3, and the same rule of slicing applies here. So the final character or the final item will not be included. All right. Now, because lists are mutable, I can target index 0 and tell index 0 to change to avocado. Now, if I print my lists, which is fruits, you can see that it works and I have avocado here. Yesterday, we tried doing the same thing to strings and you realize that we could not edit strings. This means that strings are immutable, but lists are mutable. I can also remove the 4.5 from my list by targeting the index of that item. And if you look at it, who can tell me the index number or the index position of the 4.5? Let me see who can get it for us. So the index of the 4.5, someone says 3. And let's change that to pineapple. All right. So when we print our fruit again, we are going to see that here we have pineapple. And this explains why lists are mutable. You can make changes to it after assigning. And you can see that we tried doing this same thing yesterday to a string and it did not work. But we've been able to do it with list. Now, one thing to know about lists is that list has special features. And so when it comes to creating complex structures like this, we need to look at the features that support what we want to do and select the right data structure. So another feature of lists that we can look at, another feature of lists that we can look at, first of all, how to enclose it using the square brackets, and you separate all the items with comma. So this is how you create a list. And when creating a list in Python, you can directly include integers, float, boolean without quotes. This is important because if you are storing an integer, you don't need to put an integer in quotes. However, if you are storing a string, you need to put it in quotes. All right. Now, to access elements in a list, you still use the same concept of indexing. So index 0 will target the first element. Index 1 will target the second element. Index 2 will target it. Index 3 will target the fourth one, and so on. So this is the same concept of indexing that we covered. All right. So With this, -1 will also print the last item in your list. Then -2 will print the second to last, which is avocado. All right. Now, to modify a list, just like I've showed you, you can target an index, let's say fruit index 1 from banana, and change it to grapes. So once you print this, you realize that banana has been changed to grape, and that's exactly what we tested. Now, to add an element to a list, we use a method called append. To add an element, we use the append method. The append method is a standard method in Python for adding a single element to the end of a list. So if you use the append, what happens is that whatever you add will go to the end. Now, these methods that you look at or you learn when it comes to list, they are the same methods that when you have a complex problem, you can use to solve. So sometimes you may want to add elements to the end of a list, and you have to remember to use append, which is a method to add to a list. So for example, we have a list here called fruit, and this is a list because you can see the square brackets and you can see the items within it separated with comma. These are enclosed in quotes because they are strings.
Hello,
If it is a
Matthew.
string, if it
Same
is a
thing here.
string,
Same thing here. How your side now?
all right. So if it is a string, then if it is a string, then you definitely need to put it in quotes. And if it is not a string, then you don't need to use the quote. All right. So if you say fruits, which is the name of the.
Hello.
If
Hello.
you say fruits,
Yeah, they hear you. Sorry, I've been.
if you say fruits, which is the name of the list, and you say dot append, you can append another element, and this will be added to the end of the list. So let me go back to PyCharm, and let's say we have fruits, and these fruits, let's come here. Let me share this well. All right, so we have this fruit. We can say fruits dot append, and even in PyCharm, the moment you type dot, you see some of the methods that you can use. So there are several methods here that you can use. Now, this fruit here is recognized as a string, sorry, as a list. And so all the methods here are methods we use with lists. At the end here, you can see that we have lists over here. If you are dealing with strings, we also have different methods for strings. So yesterday we introduced some of them, and then I could see from your presentation that you were able to learn some more, like the replace and the split. They are all methods you can use when it comes to strings. Now, with this particular list, we have a method called append. And with this append, we can use it to append any item to it. So let's append kiwi. And when we print this fruit here, we are going to see that the kiwi is added to it. So when it comes to lists, apart from creating the list here, you can modify, can also add, and most definitely you can also remove from the list. All right, so to remove an element from your list, we have a method called remove. We have another method called pop. And this remove method, you use it when you specify the value that you want to delete. You can also use pop, and with pop, you specify the index number of what you want to delete. So when we go back to PyCharm, I want to remove this from here, list one. Now, list one here, I can choose to use pop, or I can choose to use the remove. Let's start with the pop. So when I type fruits, when I use the pop, fruits.pop, I'm supposed to provide the index of this. So when you count the index, we have 0, 1, 2, 3, 4, and 5. Once we add this to it, we can pop out fruits. Sorry, we can pop out list one. And when we run this again, we can see that list one is gone. And we have our list without it. Now, all of these talks about the versatility of lists. And so if you have a list, you can manipulate it in various ways. You can store data directly into it. You can also add, and you can also remove data from it. Now, let's remove apple. So we can type fruit, and we can go ahead and say dot remove, and we can say apple. And when we run it, you can see that apple is no longer part of it. All right. So what we have seen with lists is that lists can be created with square braces or brackets, and we enter our items in different data types, and we separate them with comma, and we can modify the items because it is mutable. We can also append, and when you append to the end of it, and you can pop or remove, and all of them will delete. With a pop, you indicate the index number, and then with remove, you type the value itself. So the value that you put in will allow it to remove. All right. So just as we tried, that is it. Now, a list also uses the concept of slicing, which we have looked at. And slicing a list refers to the technique of extracting a portion of a list to create a new list. Just like with strings, we were able to create substrings. With lists, we are able to create a new list out of the main list using slicing. And it works with the same concept. You begin with a start index, and then you introduce your column and then the end index. So we have a list called my lists, and you can create a new slice and extract from the my list using the index numbers. All right, and it says that it is important to understand that in slicing, the element at the end is not included in the selected range. So this is the same as we saw with strings. If you have 0 column 2, it will extract only 0, sorry, 0 column 3, it will extract only 0 up to 2. All right. All right, so if we have a list like this, we can also do slicing on it. Just like we already tried, we can print our fruit, and this time we can say we want 0 column 3, and when we run it, we have only this. So the concept of indexing, the concept of slicing, they all work with list. All right. So it says omitting and negating indices in slicing. Now, all the concepts we learned about slicing, you can apply the same to lists. You can have nothing column 3 or 2 column nothing. And 2 column nothing means slice from index 2 to the end. Column 3 means slice from the beginning to index 2. This means excluding index 3. So this is the same thing we have looked at when it comes to strings. And if you slice like this, you slice to create a copy of the entire list. All right. If you use a negative index, you can also slice from -3 to the end, and so you get the last 3 items. If you slice -2 to the end, you get the last 2, and then -1 is just like using index to pull out just that particular last item. You can also extract from 0 to -1, and let's try that and see what we will get. If we say from 0 to -1, let's see what we will get. All right, so from 0 to -1 means from the beginning to the end. So over here, if you look at our real lists, it ends here. It ends here. Let me clear all the manipulations here. Let's run it again. And you can see that it ends at true. So the list 1 also did not appear because with slicing, the last element is not included. All right. Now, if you want to search for an item within a list, we use what is called the in keyword. So Python provides a convenient way to check if a specific element exists in a list using what is called the in keyword. So we have something called in keyword. So please type in the chat for me, IN. This is called the in keyword. This word returns a Boolean value, yes or no, indicating whether the specified element is present in the list or not. So we have what is called an in keyword, and it is very simple to use it. If you have a list like this, you can check if something exists within it. So let's go back to our list. Let's go ahead and change 5 here to avocado. Let's change 4.5 to pineapple. Let's change this to let's change the last one to something like kiwi. All right, so let's say we have this. We can go ahead and search if something exists within it. So we can say that if apple in fruits, so this is an if statement, but we use the in keyword because we are dealing with a sequence here. So later we'll talk more about sequence, and within a sequence, you can create a loop over a sequence. You can also use the in keyword to check if something exists in the sequence. So if apple in fruits, then print yes, else print no. So this will check if we have apple in the fruits, and if we have apple, it will print what we said it should print, which is yes. And let's check if banana exists in the list, and it can tell us that no, banana does not exist. So here we use the in keyword. We use the in keyword. So if something in the list, then do something or do something else. All right, so this is the in keyword that we use Python. All right, so for now, this is what you need to understand about lists. So when you see a variable like this, you know that this is a string. If you see something like this, you know that this is an integer because the value is an integer. When you see something like this, you know that this is a float. And when you see something like this, you know that this is bool. So when I put my mouse on this, I'm going to see that this is string. I'm going to see that this is int. I'm going to see that this is float. And I'm going to see that this is bool. And so what Python expects from you is to be able to identify these data types. Now, these ones here are complex data types, and so we call them containers. We also refer to them as data structures. When it comes to using Python in the real world, we are going to be using more of lists and dictionaries and tuples to solve real problems. When it comes to the basic data types, they are just used to assign single values. But then when it comes to providing real solutions, you are going to use your knowledge in lists. And so it is very important to take a look at this particular container or data structure and know how to work with it in Python. All you have to do is to begin with the square brackets, enter your items, and separate with comma. Now, if you look at all these variables, they are storing individual values or single values. It is okay to create a variable for a value. It is perfectly okay. But sometimes you can create just one variable, and instead of storing just one value, you can make it a list and store all the values within it. You can store all the values within it, and it works. So you can see that this saves a lot of time, saves a lot of space, and allows you to be able to do interesting things. Now over here, they have underlined list because the word list is reserved. So you shouldn't name something with a reserved word. For example, lists is known in Python, is reserved in Python, so don't say list. You can say my lists, and that works fine. Now, if you're able to save your values like this, with the concept of slicing, you are able to access any of them. If I want to access John, I can access John like this. If I want to access the age, I can access the age like this. If I want to access the price, I can access the price like this. And if I want to access the Boolean value, I can also access like this. So when it comes to writing code to solve real problems, most of the time we are going to be using structures like this to store our data. Although we'll still be using the basic data types, you'll be expected to think more in terms of lists and use lists to solve problems more than solving problems with single values like this. All right. Now, when we started, I mentioned 4 data structures or 4 containers, and we have talked about lists. Who can tell me all the 4 that I mentioned? So we started with lists. Which one else did we mention? I gave you 4. So let me see if somebody can tell me any of the other ones. So we have lists, and we also have sets, we have tuples and dictionaries. All right. And if somebody can remember the basic data types in Python, I also give you 4. So mention the basic data types and let me see. So okay, Peter, you gave me 3. So when it comes to the basic data types, you can list them. So the basic data types, let me see the first person to give me. So Ivan says we have int, we have bool, we have float, and we have strings. So those ones are called basic data types. Now these ones, you will hear that they are called complex data types. You will hear that they are called containers. You also hear that they are called data structures. So when we talk about data structures in Python, you should think about lists, you should think about tuples, you should think about sets, and you should think about dictionaries. To work with a list is very simple. That is what we have demonstrated over here. All you need is to create a variable and put your items in the square brackets. Remember, you are not trying to access an index. To access the index, this is where we place the square brackets. But if you use the assign operator and you assign to this, Python knows that you are working with a list. So whether you have a value in it or not, Python will tell you automatically that you have a list and you are working with a list. All right. Now, apart from lists, we also have what is called tuples. So in today's lesson, we will look at the list and we'll look at tuples. Now, a tuple is very, very similar to a list. It is another type of container in Python. It is super, super similar with very, very few differences in their features. And so when there is a problem to solve, you need to look at which one has the features to solve the particular problem or challenge you are trying to solve. Now, one of the few differences here, number one, is that tuples are created with parentheses instead of square brackets. So the number one difference you see with tuples is that instead of this, you are supposed to store your data in this. Now, in Python, there are very, very simple things that will be used to test you. If you see this, you are supposed to know immediately that this is not a list. If you see this, you are supposed to know immediately that this is a string. If you see this, you are supposed to know immediately that this is a list. If I go here, I'll be told this is a list. And if you see this, you are supposed to know immediately that this is a tuple. All right. So Python has different ways of storing data, and you can store as a list and you can store as a tuple. All right. Now to create a tuple is the same as creating a list in Python. A tuple can also hold multiple data types, just like in list. This is a tuple Python. I can print my tuple, and when I run it, I will see that my tuple is printed. So what is the difference between a tuple and a list? The first difference is what we have seen already. A list is enclosed in square brackets, and a list is mutable. When it comes to tuples, we are going to see that tuples are immutable. Immutable. And this presents the most important difference between lists and tuples. And so sometimes there's a problem and you want to solve with a list or a tuple, but you need to remember the features of lists and tuples. With lists, you can modify. With tuples, you cannot modify. So let's try accessing some of our values like, oh, sorry, 0. When I do this, I can print this. Let me just put it here and print it. And when I print this, I'm going to see that index 0 has a value of 4. So we have the 4 here. So the concept of indexing also works with tuples. Everything is the same it also works. You can see that index 1 is Apple, index -1, index -1 is true. So this is the same concept. It has the same features. The only thing here is that if I come here and I say that my tuple index 0 should be changed to avocado, then we are going to have a problem here. And for this particular problem, you are the only one who will understand it because of what you know about these data structures. This tuple does not support item assignment. So when you see that it cannot support item assignment, it means you cannot assign to any of its values. You cannot assign to any of its values. Just like we saw with strings, we couldn't assign. This means that you cannot modify this. So once a tuple is created, it is locked in memory. It is an object that cannot be modified. That is how it was created by the Python developers, so that you can create data in a structure that cannot be changed. That cannot be changed. Let's see if my tuple can be reassigned, just like we studied or we learned about strings. Let's say if this can be assigned to mango and let's say pineapple. If we try printing my tuple, let's see if it can be reassigned. So you can see that we're able to reassign it. We reassigned it to mango and pineapple. All right. All right. So the same concept we looked at in our data types lesson is the same. The same concept we looked at with indexing and slicing. They are the same. Tuples also have methods that it works with. Now, a tuple is a sequence. If it's a sequence, you can check if something exists in it. So I can say if apple, because apple is a string, I'll put it in quotes. In my tuple, print yes, else print no. So when I run this, I'm going to see yes, because this is also a sequence. This can be used for a loop. This can be used to, the in keyword can also be used over here. Very, very similar to list. The only thing is that this does not allow item assignment. It means it is immutable. So whenever you are being tested about these data structures, mutability is a big question because it actually determines whether we will use a particular data structure or not. All right, so we have seen that lists are mutable, but tuples are not. We can see that lists are created with square brackets and tuples are not. Even though I have called this my tuple, Python doesn't care about how I call it. If I change how I enclose it to square brackets, now it will be seen as a list. So if you check here, you can see that it's a list. All right. PyCharm has done this to tell you that you have used all these data types in your list. That is why you are seeing it this way. If I remove some of the data types and I have only strings, PyCharm will tell me that, okay, this is my list and there's only string in it. All right, so that doesn't mean much right now. What we need to understand are the differences between the list and the tuples. All right. With tuples, you can create a tuple of numbers, a tuple of strings. You can create a tuple of mixed data types. This means that you can use any data type in a tuple and it works. Apart from the fact that tuples are immutable, they also behave just like lists. All right. To create a tuple, you just use parentheses, separate the items with commas, just like we have seen. When it comes to the different data types, like an integer, you don't have to put it in quotes. Just as we have here, the 4 was not in quotes because this 4 is an integer, but this must be in quote because it is a string. So in Python, whenever you see string, you should be expecting quotation marks, whether single or double quotes. To access a tuple, you use the same concept of indexing, just like I mentioned. Once you say index something, you are going to get it. This applies to strings, applies to lists, applies to tuples as well. All right. So you can use -1 to access the last tuple. So you can see that almost everything we've studied about lists, they can also be found in tuples. If you want to search, you can use the in keyword, just like we discussed. All right. So lists and tuples are very, very simple, and they are super, super important data structures in Python. In Python, most of the time you are going to work with 8 data structures or data types. A tuple is regarded as a data type. So if you are asked about data types and you see tuple, a tuple is a data type. The only difference is that a tuple is not a basic data type, it's a complex data type, and it's also called a data structure. Even the basic ones can be called data structures, but they are very, very basic, and so we just refer to them as data types. When we resume, we'll look at other data types like set, and a set is another data structure that we'll look at. And the difference between sets and lists we are going to discover. One of the first differences is how you enclose it. Now, we are going to see that dictionaries and sets, they all use these curly braces when you want to enclose them. So when I put my mouse on this, I'll be told that this is a dict. So a dict is also a data structure in Python, and a set is also a data structure. However, if I come in here, even though it says it's a dict, it is seeing it as a dict. If I come here and I say I have apple, I have avocado, now it has seen that this is no longer a dict because of how I have stored the data. Now, when I go, it will tell me that this is a set. All right. So the data structures, we have list, we have tuples, we have set, and dictionaries. In Python, there are certain things that you cannot forget, and these 8 data types are one of the key things you can't forget. You need to remember them. In our next lesson, we will discover how come Python has seen that this is a list and not a dictionary, because dictionaries are stored in a different way. Lists are also stored in a different way, and they all serve different purposes. When it comes to solving real problems using Python, you should be thinking more in terms of list. You should be thinking more in terms of tuples. You should be thinking more in terms of set, and you should be thinking more in terms of dictionaries. If you can think more in terms of these data structures, then it will be very easy to implement your Python knowledge to solve a problem in the real world. When we advance to data analysis, we are going to see that the same concept of data structures here is the same concept we are going to use with libraries like pandas and numpy, because they also work with advanced data structures and allows us to store multiple values within single variables and to manipulate them. So thinking in terms of sequence is really helpful to upgrading your knowledge in Python. And so instead of storing just one value in one variable, you can store a collection. So we call this a collection, we call this a sequence, and this particular one is called a set. All right. So at this time, what I'm going to do is to give you a few minutes to prepare for your test. And the test covers the concept we have discussed just now. And you can see that everything here is straightforward. And if you follow it, you realize that it's very, very simple. So everything we've discussed, we can discuss it in 5 minutes. All right. The only thing is that if you're a beginner, sometimes the way you see it, the way you look at it, may be a little different. You may see it in a different way, but it is as simple as we have discussed it. Once you understand how to access the index values, once you understand slicing, once you understand that with lists, you need to use square brackets, once you understand that with tuples, you need to use parentheses, once you understand that if you want to search, use an in keyword, it is straightforward. It is straightforward. All right. So we are going to take about 10 minutes break. And after the 10-minute break, you will see the questions in your email. There are 50 simple questions to answer, and you are given 50 to 60 minutes to answer them. And this is going to be your test that covers all that we've studied so far. And this is also the Module 1 examination, like we announced before class. So let's take a few minutes break, and after that, you'll be given the go-ahead to start the examination. Now, everyone should take this, and let's see how you understand the concept so far. So thank you very much. I'm going to see you after break. All right, so if you are done, please put down in the chats and add your score to it. Let's see. So congratulations to all of you. You've done really, really well. Done really, really well. I'm very, very impressed. And I'm also happy that all those who have posted did well. I'll check the full list to see if some people didn't do well, but I'm confident that almost everyone did very, very well. So that is how it is. This is how to begin. And in module 2, we'll top up and build our confidence in Python. So if you succeeded, you will receive a mail to get congratulations on your success. And those who are looking for admission, we will review your work. And if you qualify, we will send you more details on how to proceed. So it's been wonderful going through module 1 with you. Next year, we will start module 2 and we'll cover 2 weeks of content as well. And by the time we are done, you'll be ready to apply Python in the real world. So thank you all very much. Thank you for your time. Thank you for learning with us, and expect more in module 2. Benedine will give the final announcements and we will end today's class. Someone got 100%. That is so wonderful. I think 2 or 3 people got 100%, and I'm really, really impressed. So thank you all. I'll see you in the next class. All the best. Bye-bye.